Ben Wallace, Oregon Air Reps. Oregon Air Reps is the manufacturer's rep for AAON. So today we have AAON air handlers. AAON's known primarily for exactly what you have up here, rooftop units. The residential or packaged rooftop units, meaning they've got compressors, and the academic straight above us is air handlers, meaning they don't have compressors. They're just water coils, heating and cooling.
The residential's got compressors?
Correct.
And the outside's just got chill water?
Yeah. Yep. They all have, except for one makeup air unit, it looks the same as the rest, but they all have heat wheels as well. So I plan on going through, I'll go through the residential side first because that's what I've got up. And just go through the unit, all the components, and we could talk about operation and maintenance, and then I'll go through one of the units on the residential side, then we can go up to the roof. So this here is just a submittal, the cover sheet, but every one of these bullets is, you know, is a highlighted feature that was provided on the unit that oftentimes distinguishes AAON from competitors. But so we have a fuse disconnect, single point power. The AAON units all have a 2-inch double wall, meaning there's a metal wall inside and outside, and it's a 2-inch thick with foam insulation, which is miles above your typical type of unit that just has a 1/2-inch insulation that's exposed and falls off after 5 years. They also have a special paint, 2,500 hour salt spray rated paint. They've got hinged access doors. You know, you don't have to have tools to get into it. All fans are plenum type backward incline fans. They're not forward curve squirrel cage type fans. The supply fans are direct drive, and so the means of balancing those is just a VFD, where the exhaust fans have a belt on them. We've got, as far as dampers, we have a damper. I'll show you graphically what it is, but it can recirculate air or bring in 100% outside air. And there's also an isolation damper on the exhaust. So when these units turn off, they close the outside air and they close the exhaust to prevent cold outside air from filling the cabinet. And they open the return so that the building return air can kind of keep the cabinet warm. And that isn't really a problem on the residential side since they are packaged and compressorized. But on this side, you've got water up there, so it's a standard feature. They all have outside airflow measurement on the outside air hood. So you've got an outside air hood. The air coming into it goes through these gold aluminized tubes, and those things just measure the airflow. Feed that back to the control system. Stainless steel drain pan, heat recovery wheel. They have a lot of filters, so we'll talk about that when we get up there. One bank of filters is redundant, so I want to show you that. It filters the air before it comes through the heat wheel, and then it filters again afterwards. And that's redundant when you have 100% outside air. You're filtering it once and filtering it again. So there is different stages. There's a pre-filter and final filter as well, but there's 2 racks for pre-filters, which in my opinion you can just get rid of one of them and save some energy because you have less pressure drop.
What is the purpose of that?
It's really because AAON is, what do they call it? A macro custom manufacturer, I don't know. They roll all these units off of the assembly line and they can do soup to nuts in applications. They can, you've got heat wheels or not, exhaust fans or not, you know, a lot of different applications. And so the double rack that is the redundant rack is really just an artifact of, if you bought this unit without the heat wheel module, right, you could filter, yeah. And so it's just a second pre-filter. And then when they put the heat wheel module on there, well, we need to filter before the air goes through the heat wheel, so you get another filter rack. Gotcha. So it really is just something we can ignore if you choose, or keep it in there. And then one of the biggest things with this is these do not have a black box package controller on either sides of the building. They have a terminal strip, and the terminal strip's, you know, very long, meaning you can control everything in the unit from a third-party controller. And that's what we've done here is automated logic is controlling everything. So there are, on the packaged units, there are, all the safeties are AON. High and low head pressure cutouts, airflow switches, dirty filter switches, high and low outside air compressor lockouts. If the outside air gets too cold, don't go into heat pump. Defrost controllers. There's a lot of things that are controlled by AON as far as the safety refrigerant components. And then there's a terminal strip that automated logic gets to control. Another major feature for AON and these particular units are the digital scroll compressors. I don't know if everybody's familiar with digital scrolls. They really hit the market heavy 5 years ago. They were invented, I don't know, 15, 20 years ago, and the HVAC industry just never picked it up. It was refrigeration or somebody else had been using it. And really it's a scroll compressor, so your scroll compressor's spinning like this, compressing the refrigerant down to the middle, right? It's like two spirals going together, and it compresses the refrigerant down to the middle. And it's a stator and a rotor, and they're operating like that. And what it does is it actually relieves pressure on the top to lift this up just 1/8 of an inch. And when it does that, it still spins. The motor's still running, and you will hear this difference. It's loud, and then it gets quieter, but it's on the whole time. So it's spinning the whole time, and then it compresses, doesn't compress. Compresses, doesn't compress. And that's on a 17-second cycle. So if you compressed for 1 minute and then didn't compress for compressed for 1 second, didn't compress for 16 seconds, you'd have 1/6 or 1/16 of your full capacity. Does that make sense? So if you say it was a 10-second deal, you could operate for 9 seconds and not operate for 1 second, you'd be 90% capacity. So these things can modulate. It's a compressor that is modulating its capacity but isn't really varying its speed. It's a digital scroll compressor, so it's on, off, or on, off, on, and that changes the capacity. The benefit of it is at all times it runs at full velocity. So it's getting the oil return every time it compresses, because when it's compressing at full compression. And then when it's not, it's saving energy. So you're able to dial in your temperatures precisely, which is nice. Because traditional compressors, you've got a number of compressors, and that's your staging is what you get to control your temperature with. And every stage will jump that temperature, 5 degrees. And so in this case, they get to dial in their temperature exactly. It eliminates cycling, so it improves compressor life, comfort, energy savings. And the biggest energy savings is when you cycle a compressor on and off, every time you cycle it off, the refrigerant equalizes. And usually there's a minimum off time, minimum on time. And that refrigerant equalizes on both sides of the refrigerant system. And then you compress it again, and then it equalizes. And every time you do that, you're kind of losing efficiency. In this case, the cycle is so quick that it doesn't give it time to equalize. And so it just keeps it, the pressure separated, and that's where your biggest energy is, energy savings over cycling compressors.
Do they use that type of compressor in a lot of different applications?
AON does. They'll use it in every one of their products. You can do condensing units, air handlers. Carrier has a few packaged rooftop units that use it. I think Liebert Data Systems is starting to use it for data rooms. Not all the manufacturers have adopted it yet, though. The big guys like Trane and York have not adopted it. McQuay hasn't adopted it.
Sounds like a good way of doing it.
Yeah, it is. And like we had talked about last week, the Daikin, the Mitsubishi, those systems have variable compressors. They have inverter driven compressors, which vary the speed. And for some reason, only Japanese manufacturers have developed that and used that technology. US manufacturers are just now starting to play with putting an inverter or a VFD on a compressor. And then you have all your oil return issues, and they got to figure all that out. But this is a not very costly. It's just a little bit more than a regular compressor. It pretty much, you can put it into a regular system. You're right. It's a great way to do it, and I don't know why everybody's not doing it.
No.
I think there's resistance.
A lot more moving parts. It doesn't. I
Yeah, it's not, and I'll show you each unit that has it would have like a standard scroll and a digital scroll, and there's just a slight difference between the two, so you see that.
Then again, a chance to compare the performance energy-wise, how many watts the compressor uses as compared to the
other
Japanese variable?
Oh, no, not compared to the Japanese. Yeah, yeah. We have not compared it to that, but we do have energy stuff that'll simulate the digital scroll versus a standard scroll. Sorry, get back in the corner. So I jumped into compressors there a little prematurely. We're still on the roof above academic, which does not have compressors. So this is just a rundown of capacities, electrical data, stuff you'd see on a regular submittal. The coil that's in these units in here serves both heating and cooling. So there's a switchover valve somewhere that will give hot water to it or chilled water to it. The heat wheels, this is essentially saying you've got your return air coming in. This is 12,000 CFM. And then zoom in here. So we got 12,000 CFM coming in from the building. We've got 0 CFM returning. So we've got all of that airflow exhausting. So, and then we have outside air coming in at, this is cooling. So it pre-cools the air. Down here would be heating. So let's say we have 75 degree air, return air coming in. As it goes out of the heat wheel cools that 75 degree air down to 41 degrees. And it exchanges that heat into the outside air. So it draws the outside air from 22 degrees up to 55. And that's what your heat wheel is doing. As it slowly spins, it heats its media up in the exhaust airstream, and then it transfers into the outside airstream, and it gives its heat up. And so it can literally take 22 degree air, bring it up to 55 degree air for free. And it just has a small motor with a wheel or a belt that spins that wheel. We'll go look at that. And that's all this here is showing. On a cooling day, it does the same thing. It pre-cools the air. You don't get much effect out of it because your building might be 75 degrees and your outside air is 92 degrees, 95 degrees. So it's not going to cool it much, but it cools it some. Here's your terminal strip. So it's a pretty extensive terminal strip. On this one, you can turn the fans on and off, change the fan speeds, turn the heat wheel on and off. You can control the dampers. There's a clogged filter switch. You've got fan speed and status and fault feedback. So there's quite a bit of stuff that it reports to the automated logic system. And so you have 2 units. This is the second unit. 2 units that are identical upstairs and one that's a little bit smaller. Here is the cross section of the unit. So I'm going to show you all the components here. So looking at the elevation, the side of the unit. So starting at the beginning, your return air comes in from the building and it has a choice. It can either recirculate through these dampers and go back through the unit, or it can leave the building and go through the exhaust. The 3 units on this side, the 2 largest units are 100% outside air all the time. The smaller unit is sometimes has recirculation. I'm not positive of how they're controlling that. But so for the most part, this return air comes in, it goes through the heat wheel, it's right here, and it goes out that exhaust fan. And so all it's doing is coming up, going through the wheel. It's heating this lower portion of the wheel. The wheel spins like this. It's heating that portion of the wheel. It spins up and then transfers its heat to the fresh outside air. These dampers are on gears, and so if these are open, these are closed. If these are closed, these are open. So for the most part, you'll always see these closed. The outside air is always going to come through here, gets heated up with the heat wheel, and there is a filter bank here, and there is a filter bank here. And those are the redundant filter banks I was talking about. Now here it's a 2-inch 30% filter. Here there's a 2-inch 30% filter, filtering that exact same air. If you were returning air, it would filter that. And in our case, it's not if it's 100% outside air. It's filtering this twice. And then right back to back with that, this filter is a 4-inch MERV 11 filter. So like a 65% filter. So that's the filter that needs to stay there. So you got a pre-filter, goes through here, then you've got a final filter, and we can choose to take those extra ones out if you desire. Then we come through a staggered coil. So there's a coil here and there's a coil here. With cooling coils, you want a certain face velocity, feet per minute, that goes through the coils. If you go over 500 feet per minute, you spit out the condensate, and it causes issues. So what they've done here is they've made 2 large coils, and they staggered them. They put the sheet metal in between so that the air slows down and goes through the coil at 500 feet per minute and then speeds back up. And so this might be faster than 500 feet per minute, but at each coil, it's 500 feet per minute. You come through those coils, you got a drain pan, then you got your supply fan, and your electric heat is right in here as it blows down. So this supply fan is pressurizing this cabinet, which forces the air down. Goes through the electric heat and out. Again, electric heat is actually on the package units, the heat pumps, not this side. The controls are all on the face of this. This is the front is right here. 2 big swinging doors, tons of room in there, all the controls. On these units, there's a lot of room because there's not all the compressor controls and everything. On those units over there, it's just packed full of stuff. It's quite full. So those are 2 larger units. And the smaller unit looks about the same. It doesn't have the large heat wheel in the back. It does have a heat wheel, it's just not as big. So it's a constant size. It goes through the heat wheel. Here it shows the heat wheel filter. On the other one, it just didn't show it. There's also a filter rack here to filter the exhaust air that's coming up before it goes through the wheel, so the wheel doesn't get plugged up. So there's a filter rack down here as well. Pretty much the same unit.
I'm sorry, Ben, which unit is this now?
This is academic side, 3rd unit. So on the academic side, there's 2 large identical units and 1 smaller unit. This is the smaller one. And the way the nomenclature is, the academic side is air handler 5-1, 5-2, 5-3. On the residential side, it's air handler 7-1, 7-2, 7-3, or makeup air unit 7-1. Any questions about all that?
Yeah, one question. How fast do the heat wheels turn?
I wish I had an RPM.
They're pretty slow, aren't they?
Yeah, you know, visualizing it, it's say a 5-foot diameter wheel, and the tip speed's probably going about like this fast. Yeah, yeah. It's got a, you know, a motor with a little teeny shiv, and then a belt that goes around that entire wheel, and so it is pretty slow. And they've shivved it to be the optimum heat recovery. I've played with them before, putting a VFD on that motor, and it's surprising how little of a heat recovery change you get as you play with the wheel speed. You got to really slow it down to not get that heat recovery. So let's talk about the heat wheels a little bit more.
Those are only on the academic side.
They're on all of them. There is.
So your units have the heat wheel.
Yep, yep. One of the things I handed out talks about the heat wheel. Recommended cleaning procedures. You're basically taking a mild detergent. You can always vacuum them, but you can soak them. So the whole thing slides out on a rail, and then it comes off in pie pieces. There's a couple clips. You can take each pie piece out, and you can soak it. And we've seen that before, say when they ran the units without filters during construction, and they got, you know, chalky concrete dust on them or something. Got to wash them. There's times when the filters, during freezing fog, for instance, the filters will saturate, freeze, and then implode. And that filter that is filtering that outside air immediately hits that filter, or hits the wheel. And so all of a sudden you got this thing rubbing against it. You know, that would be a time when we've had to wash them. Or you can replace them. But ideally, they say that they're self-cleaning for the most part. You've got outside air going through it this way. You've got exhaust air going through it this way. So after every rotation, you've blown through it both directions. And so if anything were to get through to it, it gets blown back out. The orifices, it's actually layers and layers of kind of a plastic paper that have little dimples that hold them offset from each other. And it's just, you can actually spread them apart, stick your finger through it. But it's these layers and layers and layers of this media that the air can pass through it, but that media traps the heat into it. And these are sensible heat recovery only. They don't absorb moisture and then give off moisture, which is another type of heat wheel. It's just a latent heat recovery wheel.
And is there a you know, quarterly, every 6 months, you know, clean?
Not on the wheels. The wheels, I'm curious if it says here.
And you said just use a mild soap solution, right?
Yeah. See, it says here in a basically a clean environment, you should be able to go 10 years before having to clean it.
Oh.
Yeah. So it's not a yearly maintenance chore. Over time, when they do get dirty, your biggest risk would be pressure drop if there was something actually stuck in it, and energy use because of that. Otherwise, it's lack of or reduction in energy or heat recovery if they got dirty. So for the most part, it's all about energy. And then.
So what kind of delta T do you usually see with the design like this? Outside air, I mean, I don't know, it depends on the outside air temperature, but you can assume some parameters.
Yeah, absolutely. We saw, what was it, 22 degrees up to, on the smaller unit, we're coming in at 75-degree return air. It cools that down to 40, so it just dropped 35 degrees out of the exhaust, and then it raises 22 degrees up to 50 degrees. So we're getting quite a bit of, 28-degree temperature rise. And that's on the smaller unit. I want to say that, oh, and then on the cooling side, it takes 75-degree air out of the building. That will cool down 92 to 82. So you get 10 degrees of free cooling if you were at your peak. And your building was indeed just 75 degrees. Whereas those larger units, even better. It's taken 92 degrees down to 80, so it's got 12 degrees on the cooling side. And on the heating side, it's 22 degrees up to 57 degrees, so quite a bit. And as far as heat recovery goes, I don't know if you're familiar with it, there's a number of different ways to do heat recovery. The heat wheel is the cheapest heat recovery component you can buy, but it's also the most effective. So in heat recovery, heat pipe is usually a popular one because you don't get any contamination between the heat and cool side, but they're only about 50–55% effective. And they're crazy expensive. They're a whole lot of copper and aluminum. The next one is the plate-to-plate heat exchanger, where you pass air through 2 different corrugated plates. That gets up to about 65% efficient. And both of those types are passive, where there's no moving parts, nothing can fail, it's probably always going to work. And that's the draw to those 2 types. This type can get all the way up to 77% effective. But you've got that motor and that belt that can fail. And pressure drop, they all vary. But this is the most effective and the least expensive. It's also the most compact. As you saw in the drawing, you know, you add a foot to the length of your air handler.
What's roughly the cost of one of these units?
Of the entire unit? Or
No,
the heat wheel?
The heat wheel portion.
I don't know. I don't know.
Okay.
I can work it up here later, but yeah, I'm not sure how much it adds to the unit with or without it, but I can figure that out.
Well, what about, can you get the heat wheel as a separate unit that could be added to other...
Any Airstream or something? Yeah. You can. We don't sell it that way. We just get to sell it in these Aeon units. So, but you can buy a module with, you know, if you have 2 fans, you could buy a module and then blow the air through that. And I found this, honestly, it basically just gives you more information about the wheels, how they work, how they're set up. We've talked about most of it. Standard pressure drops, and then how to get your effectiveness, your heat wheel efficiency, the calculation. If you were to take all these temperatures around the unit. And in that submittal early on, I was showing you the pressure drop. That would be another good way to determine whether it's clean or dirty, is you could look at the submittal and see if the pressure drop is still as it was new. Going over to the other side of the building, we have 4 air handlers, packaged rooftop units. They're actually heat pumps. And we have 1 makeup air unit, which is just a heat pump without heat wheel. And it's called makeup because there is no way return air can get to it. All it is outside air. But those air handlers are basically everything that Aeon can pack in a unit. They are air source heat pumps. They have heat wheels, electric heat with SCR modulation, digital scroll compressors, a terminal strip for control by others. They've got everything.
That's the residential side?
Yes.
The 70 whatever?
Yep. So we've seen most of this, so we'll blow through it. Again, now we just have even more performance information. We've got cooling, we've got heat pump heating, and we have electric heat. Here's your pressure drops if you were wanting to see, say like the heat wheel. The heat wheel pressure drop is 0.82 inches when it's clean and new. if you were to go take that pressure drop in 5 years and see that it's 1.5 inches, you'd probably know, okay, now I need to clean that.
Is that this here?
No. No. This is the submittal data, which doesn't usually make it into the O&Ms, but I'd be happy to email it if you want it. These have 2 power connections. So they have 2 disconnects, and that's for smoke evacuation, I believe. So the controls and supply fan, heat pump is all on one disconnect. Exhaust fan is on a different disconnect. So that way, I think they might have the exhaust fans powered off emergency power or something, so that if the power were to go out in the building, they could still evacuate smoke. This is an important chart on each of these. It shows you the heat pump performance subject to outside air temperature. So here we have outside air temperature, and here we have how much heat pump capacity you're going to get with that outside air temperature. So with a heat pump, you can only harvest so much energy, so much heat out of the outside air, right? So when this thing's in heating mode, as the outside air gets colder, you get less heat pump heat. And so you would then start using more and more electric heat to supplement that. And then at a particular cutoff, here at 27 degrees, below 27, the refrigerant pressures are too low to operate, and therefore you're only going to use electric heat.
Is there a safety to take the compressor out?
Yes. And right now, I just confirmed this yesterday, the first stage of each of these, there's 3 of the units. The 3 smaller units have 1 circuit, 1 compressor, 1 refrigerant circuit. And those are all set at 27 degrees to lock out. Lock out in heating. In cooling, they lock out at 45 degrees. So you don't compress or cool anything below 45 degrees. The 2 larger units are 2 circuit, 2 compressors. And so you have a lockout for each circuit. The first circuit's 27. The second circuit, the first circuit is 25. The second circuit is 35. And that's just AON requires the 2 to be 10 degrees apart. I don't really know the reason to that. But condenser fans on the top. Otherwise, all these components are just like we saw before. There's just a condenser hanging off the side of the unit. And then the control cabinet on the end is has a whole lot more in it than with those other units. There's, instead of the water coil that could do hot water or chilled water, this is a DX coil, and it can heat or cool because it's a heat pump. There's a defrost controller in each unit. When that defrost controller activates, it then turns on the electric heat so that it can give neutral air while it's in defrost mode.
Are those the units, Ben, that have this digital scroll?
Yes. Yes. These have digital scroll compressors, and they also have, these things have some fancy curbs too. This is a spring isolated curb. It's got a rail on the top to keep the vibration of the unit isolated. It also has internal ductwork inside the curbs to where you've got 4 duct connections, 2 on each end. I've never come across a curb like this. It took quite a while to coordinate that with the sheet metal and all that. So they also have electric heat with SCR modulating control. And that an SCR controller is the means of modulating electric heat. And so it's just like that digital scroll where it pulses on, pulse with modulation. And so depending on how long it's on, how long it's off is your capacity control. And when you put an amp probe on that, it's crazy. You watch it, and 1 second it says 9 amps, and the next second it says 60 amps. It really is pulling current, not pulling current. And if you like attach that unit straight up to a generator, for instance, it'll cause havoc on that generator, just because that truly is how it's supposed to work when you're measuring it. And you'll see the same thing on that digital scroll as it modulates your pressures. You know, your pressures change each time it cycles, your amperage changes, the sound changes. Again, there's an extensive terminal strip. This one has your compressors, and so for every compressor there is an enable-disable point, and there is a 0 to 5 volt capacity point for every compressor. And beyond the compressor and the reversing valve for the heat pump, it's essentially the same points as you see on the other unit. Smaller unit, got 2 condenser fans.
What's telling it to switch from heating to cooling?
The automated logic controls.
So it's some sensor in the zone?
Yeah. Yep.
It has nothing to do with the outside air then?
No. Yeah.
Zone 10.
Right. I'm pretty sure that, yeah, I'm not sure, are they serving the hallways? Or, so I'm not exactly sure what zones they serve and what switches them over precisely, but yeah, it's, I think they control the discharge air temperature to maintain, say, the hallway temperature, or maybe they blow a little into each room, I'm not sure. So those are the package units. Again, there's 4 on the residential side. One of them is the makeup air unit. So it's got a little less, it is still a heat pump, outside air, 100% outside air heat pump, which is kind of a rare one. Does not have the heat wheel. It does not have this return. All it is outside air coming in. You filter it, you go through a coil, you go through the fan, and you're out. It does have electric heat for backup. Because this thing, without the heat wheel, has to take your 22-degree air, you know, all the way up to 80 or whatever to serve the space.
That's the makeup air?
Yeah. Much smaller. And the wiring diagram. Laminated on each unit on the control access door. They're all color-coded, and the wires match the color coding. So it really helps in troubleshooting. They're laminated. Hopefully they'll be with you for the life of the unit.
Are they labeled also?
Yeah, for the most part, every single component has a label somewhere near that component. Whether, you know, if it's a sensor or whatever. And then there's acronyms galore, and the legend is in the ladder diagram. So down here, every acronym that's used is defined. So whether you want it in the ladder diagram form or the schematic.
Are they both in the unit?
Or point to point, I guess. Yeah, they're both in the unit. And so here's your terminal strip again. And so automated logic would be on this side of the terminal strip, and everything else is Aeon. So if you ever look at that terminal strip, you can, I think at the top side is Aeon, the bottom side is automated logic. Automated logic installed isolation relays on everything, so they have their own power, and they're operating their relays so that we can use our own power to pull in our contactors and things like that, so that the two are separate. Got a VFD. These wiring diagrams show Yaskawa VFDs, but we've installed ABB VFDs. So you got your VFDs here. This is a digital scroll controller. So this is a standard scroll compressor. This is a digital scroll controller and compressor. So there's a little black box, which is the device that does the compress, don't compress operation and modulates the compressor. One thing to note on that black box, everybody at some point goes up to one of these units, sees that black box, compressor's not running, and they see the little red light blinking. And it says alert. It doesn't say alarm, but it says alert. And there's 9 different codes. You know, if it blinks 9 times, it means this. If it blinks 2 times, it means this. Those are all alerts or warnings. They're not necessarily alarms. Because this is a device that's made by Copeland, and this is a device that's made by Aeon, they're using that Copeland device, but depending on how it's controlled, like there's timers and anti-recycle timers. There's various things that will hold that compressor off when it thinks it should be on. And all that light is doing is saying, half of me wants to run, but something else is telling me I can't. Maybe the airflow hasn't made yet. Maybe the timer just hasn't cycled through yet. And so there's other components that'll cause that little red light to blink, and it's not necessarily an alarm. Here's your outside air temperature lockouts to lock out heating or cooling, lock out the compressor for heating or cooling. But just a standard wiring diagram. Electric heat in the bottom. And that's that. If you got any questions, we can go over more here. Otherwise, we just go kick the tires and show you the components.
Do we have any units on the roof that are natural gas heat?
No, no, all electric heat for backup. Yep. There's one unit, just so it's not a surprise to anybody, that's on that corner over there that has a significant amount of ice on it, and that's being
Brought up already.
that's
Yeah, we've seen it.
being troubleshooted. Yeah, you already see it. Yeah, it's almost 4 inches. I ran it through 3 defrost cycles yesterday, and I got it to drip a lot, but that's about it. I never got anything to, ice to bust off or not. So the defrost controller I proved worked. However, that defrost controller is using a temperature sensor or something, to determine when it needs to go. That could be bad. When I was up there, there's a jumper where you can set the intervals between defrost cycles, and there's 30, 60, and 80 minutes between defrost cycles, and it was set at 80. So if the thing runs and then cycles off, runs and cycles off, it never ever gets to that defrost cycle. I changed it to 30 so that it'll be more actively defrosting, but I think there's probably further troubleshooting to do because the other units are not doing that. So.
Are the other units set to 30 on that jumper? Or were they 80 also?
I did not look. We can go do that. I can go do that.
Any other questions before we head
It's
out?
not reversing the gases why it's not defrosting, or?
No, so the refrigeration cycle will reverse. So it'll actually be running and heating. So it's taking heat from that condenser coil and pumping it indoors. And so that condenser coil gets really cold. And if it's really cold outside or raining or whatever, it'll frost up, it'll freeze, and then it reverse cycles and actually puts the unit into cooling, which takes heat out of the indoor air and pumps it outside and heats up that coil. And while it's doing that, it's cooling the air going to the space. And so you would get 50-degree air blowing on you in the middle of winter. So then electric heat is only on that airflow to make that air coming into the room more warm, but it doesn't actually run gas or electric heat on the unit to defrost. All the defrost is reversing the refrigerant cycle.
It doesn't drop any fans?
The condenser fan was operating when I ran it in defrost. I don't actually know if that's typical or not. Yeah. The condenser fans are supposed to cycle on head pressure. So I would assume that the head pressure was such that it thought it needed to run. And if it didn't, that it wouldn't. But I don't know.
Each fan's got its own head pressure control?
Not sure.
There's a whole bank that's going out.
I'm not sure. It might be the whole bank. I'd have to find it on there.
Well, how many compressors are in these units?
The 2 larger units have 2 compressors. The 3 smaller units have 1. And each compressor, when there is 2 compressors, has its own circuit. So here's the 3 condenser fans. And this must be maybe the head pressure relays. I'd have to look at the acronyms, I'm not sure. belt driven, but it is a plenum fan, backwards incline, pressurizes the cabinet, forces the air out. This is actually the airflow monitor transmitter. So it's reading the air that goes through each one of these holes, averages it, converts it to a feet per minute, and then the area of that opening is computed in here to give us a CFM, cubic feet per minute. If you can read AON, it means it's closed. That's what they say.
They put the two side by one here, and there's another exhaust on that side.
Yeah.
Is that not to interfere with the outside air intake?
Yeah. Yeah, rather than putting it right behind it, yeah. Yep.
Makes sense. That's a good idea.
You know, it's packaged, but they try to separate it as much as possible. The smaller units actually do have it out the back. So here's the heat wheel.
If I could reach the top.
So you can see the outside air intake on the top does have a filter rack. It's just a 2-inch filter rack. And I suggest that always be there. So it saves the heat wheel.
That's pretty size filter, 2-inch?
Yes.
Right. Like you want to slap up on top. So.
Oh. That's good.
Yeah, it's not
there you go. A little better. So there's actually a double wheel in here. There's one wheel here and one wheel here. If you took this panel off, you should be able to slide this one out. There's a door on the other side to slide the other one out the other way.
Oh, I can see it doesn't move very fast, does it?
Right. And we could turn it off if you wanted, but there you can see the pie pieces.
You kind of see right through the screen right there. It's not moving very fast.
No, it's not.
I think each one has its own motor.
Faster than one over in building 30.
You also notice the Belimo actuator on the top here and on the bottom. Those are bypass dampers. So I believe they're all closed on this entire project. They're intended that if you were to try to put more airflow through the unit, say your application was different or you wanted to ramp it up, you could open those. And those are modulating damper actuators that Automated Logic has control over. They just keep them closed because they don't need to open. But if you wanted to modulate temperature, for instance, this exhaust would allow some air to not go through the wheel. It would give you less pressure drop and less heat recovery. Same on the outside air side. You could bring fresh air in without heat recovery. So if you were trying to do economizers, for instance, and you wanted 55-degree air, the air was 45 outside, but your heat recovery is going to bring it all the way up to 65, but you want 55. You could open those up and get less heat recovery. And that currently is not part of the sequence, I don't believe. It might be.
There's two wheels and one motor.
No, there is another motor on the other side. One motor per wheel.
And that drives, is there a shaft or something? Or?
It's a belt.
It's a belt. Oh, I see. There's it.
Yeah, there's a...
So you pull that, panel, you pull the belt, and then the whole thing just slides out and you have 5 pieces.
Yes. Yeah. Yep.
Get busy. Pulling that panel.
And I've had to take a wheel out before. There's tricks to it. Your knuckles get skinned a bit, but...
What keeps those pie pieces in place? It's just a frame.
It's a stainless steel frame that holds all the pie pieces in, yeah. And then there's a clip, say 5 clips per piece or something that hold them together. Actually, I could stop it. Heat wheel, start, stop. VO2. That stop it? Yeah. So I just turned the binary output from Automated Logic that controls that start stop. I just turned it off so the unit can keep running. But so if you put your finger in there and you wiggle it, you can actually get your finger to go through it because it's those pieces of paper.
Like a broom almost. Or
yeah.
something, yeah.
I mean, they're pretty resilient. It's not like you're going to bend them. They just bounce back.
Not like a coil fin.
Yeah. You can do that with a coil fin too, right?
Yeah. Pretty fast.
Cut your cuticles off.
That looks like a kind of velvet or something. That felt. It's something else.
If it's going 100% outside air operation, that same air up there gets filtered here. And this is a 2-inch rack and a 4-inch rack. That 2-inch rack is redundant. So you can leave it in. A 2-inch rack, 30% filter is about 0.2 inches of pressure drop. So it's not a huge worry, but they are redundant. Yeah.
So the next time around when we change it out, we'll just leave it out.
Yeah.
It's a little bit less maintenance.
Yeah. You might even be able to, they might still be fairly clean. You could move them back there.
Now that one.
I can get it if you want.
I'll throw Jerry up there. Where is he? You'd think they would have like a bar or something that would just both of them.
Yeah. Oh wait. Which is which here? Okay. So there's a DX coil right here, and there's a DX coil over there. So these filters are for one coil, those filters are for the other. They're essentially the same filter rack, so these two, or these would be redundant as well. And as you can see, they are pretty darn clean.
So just that first one there,
Yeah, this first one, recommend to take that out. Yeah, that one should be,
Wow.
looks like it's missing down there. Yeah.
There.
Oh, well, you know what? Oh, it's right there. Where'd you get this one?
This one was over there.
Oh, okay.
But those two are that
Yeah.
far corner.
I'll go on the other side and get those.
But I was wondering why they wouldn't slide.
Yeah. So this is the usually what is the economizer dampers. In this case, what it allows, you can see a division.
Always be closed.
Right. Unless it's unoccupied hours, and I don't know if it's 24/7. I don't think, but these are outside air dampers, and so these will close when it's unoccupied, and these would open up to get the cabinet warm. We can go around the other side to put those other filters in.
They're either or. They don't blend.
Correct.
Okay.
They're either or. Yeah, all these gears will mesh together and cause the others to open up. Yeah.
But it's going to be one condition, I guess.
Yes. Yeah. Well, you can modulate, but yeah, they're always opposite of each other.
Oh, right. So sometimes they'll be in the middle.
Yeah. Yeah.
Depending on mixed air temp.
Yeah. Well,
Just wondering, we got one over here.
this unit and the other large one is 100% outside air, so they're always going to be either or. Yeah. So
And these are redundant filters over here too?
yes, these ones here. Yeah.
So we can take out those 2-inch filters on both sides of that.
Yeah. This coil and that coil. And then this piping is simply field piping that got them to have piping on this side of the unit. The standard coil piping is on the other side, but you can draw it through the unit so that, because they must have had the piping connections in the field down here. Your supply fan axis is going to be in here. This is the one that you do need tools to get into. Got to take those 2 screws out. And so you've got a large plenum fan similar to the one in there. There's 2. There's one on this side of the unit, one on the other side. They're direct drive, so they've got a motor attached directly to the wheel, no belt. So you don't ever have to change belts in here. That's a good thing. 2 disconnects, one for each service. I think this is the heat pump, supply fan controls, and this is the exhaust fan.
Where are the lubrication on that fan?
Probably on the bearing.
Okay, lock it out, get in there. And
Yeah. Yep. And there is a bearing on each side of the wheel. There's a bearing on the inlet and on the outlet. And sometimes the plenum fans, it's just the bearing on the outlet and there's nothing on the intake, but there's one on each side. Here's your laminated control color-coded wiring diagrams. Your ABB VFDs, we have a separate training session for ABB. But like you can see, there's tons of room in here. And that's because you don't have gas heat or electric heat, don't have compressors. It's just very simple. You've got all your contactors. These are the, well, there will be isolation relays that Automated Logic will be installing. Right now, they're controlling everything directly. This is that long terminal strip I was talking about. So this is where you can control everything in the unit. And then they field installed fire alarm stuff here.
So quiet, it's nice.
Yeah. And then up here are your Magnehelic pressure gauges for filters. And they all read 0. It must be very clean, huh? Did you put those in? Okay.
Well, a lot of times you zero it for when you put in a clean filter, you zero it, and then
Okay.
When it goes over an inch
Yeah.
above,
So they probably haven't been zeroed out.
yeah.
There's also a filter switch that makes for Automated Logic. So on your graphics, they'll tell you about that. But there's a exhaust air filter, differential pressure, outside air filter, differential pressure. So they have filter switches for the DDC as well.
So the large brake drive is for, of course, this
Supply fans.
the
Yeah.
small one is
Exhaust fans. And that's a good observation. There's one VFD, but there's 2 supply fans. There's one VFD, but there's 2 exhaust fans. So that VFD runs both in parallel. And the supply fan is just bigger horsepower. Yeah.
And that's a filter static?
Yeah, up there, filtered. Yep. And like right now, we discovered this last time, you can see this is only running at 26 Hertz. That's 26 out of 60. So it's creeping along. And we looked at the graphics and it's doing what it's supposed to. The sequence controls the supply fan to maintain a duct static pressure. And then it controls the exhaust fan to match the supply fan. Or the exhaust airflow to match the supply airflow. And so right now the exhaust, there's rooms that aren't exhausting quite enough. And it's because this exhaust fan is being held back from running full speed because it matches this. And that would be a building pressure issue. So I don't know how to get around that. That's,
Oh, that's stinky,
yeah.
we were talking about that last time.
If you lifted this up, would you see just an open plenum type effect, or is there different?
You'd see 2 ducts. Or, yeah, two ducts. One on the supply, so there's a good square supply going down. And then on the return side, let's go look at it. Nope. Oh wait, it's on the other side. Oh, I know what it is. It's right here.
That one I can't.
It's down here. The return air duct is between here and here, straight down. So it's pulling up the air right now and exhausting it,
Okay.
or it can return it.
Right. And that duct moves all the way down and feathers out. Or
Yeah, feathers out underneath. Yep.
Where is this? Didn't you say there's a filter down here? Is there a filter that?
Should be a filter. Here it is. Gosh, how do you see it? It's right here. How do you get to that?
Yeah, how do you get to that?
Let's go look on the other side, maybe.
You gotta take all that off to get to it.
Oh yeah. Yep. So
you see that, Jared?
here's another one. This is a filter rack access. So this return air is coming up here and it's exhausting through the exhaust fan. There's a filter rack right here. You can see it here. So
That's the return,
less ideal.
building return air through the
Yeah,
wall.
through the wheel. So you should have to change that out less often because it's return, or it's building air.
Well, yeah, the buildings are filthy.
Yeah.
Is there a gauge on that also in there?
Yeah. There's 3 gauges, 3 filter racks. Yep. There might be better access on the other side, but I bet you it's the same.
Well, if it's like these ones, there's a block in the middle. You can't slide your filters all the
Oh,
way.
okay.
You can only do 2 and 2.
Okay.
So that might be this.
Yeah, it's got to be a mirror image, I bet. So the other unit is the same size over there. Just about everything's identical. Horsepowers are slightly different because the airflows are slightly different. But components, everything else is the same. And here's the smaller unit. You've got 1 exhaust fan, 1 exhaust. It's blowing everything out that way. You do have exhaust isolation dampers which open and close based on the fan command. You can see them up inside here. You can see your outside air filter there. So that's the first filter you come to. And then your return air is coming up here. You can get to this filter a lot easier. This is your exhaust air filter.
Yeah, there's that plate on the other side, so.
Yeah, it's all one-sided access for this one.
That one might be one-sided.
Oh, okay. And yeah, this is single heat wheel. Remember, we had a lot less heat recovery on this, or maybe not a lot, but less heat recovery. There's only 1 wheel.
So why are they taking pictures of this one?
The specifications called for cameras in the units, and I think that's a learning tool. I think there might be integrated into the graphics eventually. So if you're at the DDC system. So just like that last unit, yeah, return air is coming in through here. It's exhausting, or it can come back through here. So this would be the redundant filter rack. And then, so these 2 ventures here. This is your DX coil that heats and cools. And here you can see your fan intake. And this one has airflow monitors on it. That's similar to the airflow monitors you saw in the outside air hood, except this is a fan intake airflow monitor. And then we have 2 accesses for controls and compressors. They've put in various controls in here. We got the 2 VFDs, supply fan, smoke detector. This is your supply fan access, so you can see what it looks like, but it's a direct drive plenum fan, and it's even more difficult to get access to it, but it's in there. Right. And this is where the compressors go if it were a compressorized unit.
Well, this one's nowhere near labeled like that first one.
No. And that's the controls contractor. Well, this one is.
Water coil?
Yeah.
Chilled water or heating?
Yeah. Yep. Yeah, it's not. Yeah, I was calling those DX coils earlier. They're not DX, they're water. Again, this is a simple one. Once we see the others, you'll see what I mean.
We should.
Disconnect. And if you ever do need parts, the most important thing is just that serial number. if you called me or you called our parts department, that's what we need. So this has airflow measurement on the exhaust as well. They must have just installed that this week. And that's mostly for learning as well. I don't know that they use that in the sequence. No, that's a difficult one to install because usually, so like you see there's a bearing there on the fan intake. A lot of times they're making all of the bearings kind of cantilevered out there on the motor side, and there is no intake bearing on, you know, plenum fans like that that are 10 to 24 inch.
So where's the return air filter? In this one? Is this it?
Yes.
Coming up here?
Yeah, yeah. So it's nice and neat.
It's okay.
See, I'm wondering, see there's that plate on the other side.
Yeah.
So I'm wondering if we open up this one here, if we can get that can't be.
Automatically reset, but the high is manual.
Right.
So it's usually one of the only things that will keep your unit from running, you know, that needs a manual reset.
Okay, this is something. It's wrapped.
410A, are they all using 410A?
Yes, it's all 410A now.
Well, yeah, just like the old town.
And these little toggle switches is what you're.
This is what designates the digital scroll. So this solenoid, when it opens up, it relieves a little bit of pressure on this diaphragm right here, and that's what allows the thing to go up and down. Yeah.
Right there, right?
So it's not actually hot gas. Some people think it's hot gas bypass, but really all it is relieving the pressure just enough so that opens and closes.
It's tied into the side. Is it holding up on that arm on the bottom?
Oh.
Is that what it is? I had it in the wrong place. Yeah. There we go.
And the units over there are basically the same, except they have an exhaust fan and a heat wheel. Yeah. Yeah, and the other's white was showing, and
Okay, so there's an indication if you tick.
yeah, you can kind of see how there's white on the back side of that.